Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. I believe you are all well. Ladies and gentlemen, I want to take you through physical science, paper 2 topic, particularly on electrochemical reaction. So this is the topic that I will actually address. However, I'm not going to go through all of it at once, so I'll just do it into sections. Right, without wasting time, ladies and gentlemen, you need to be able to understand the following concept under electrochemical reaction. This is paper 2 topic in physical science. Number one must be able to define what is reduction and oxidation in terms of electron transfer, and you must also be able to define what is reduction and oxidation in terms of something called the oxidation number, which means for you to be able to define what is reduction and oxidation in terms of oxidation number, you need to be able to understand what do you mean by oxidation number and how to actually calculate it or how to actually represent it on an element or on a compound. So again, you must be able to define cathode and anode, which are electrodes. And you need to be able to define the term oxidizing agent and reducing agent in terms of electron transfer. One must also be able to, so it means I've addressed the cathode anode, the reducing agent and oxidizing agent. You must know the two types of electrochemical cells, which is galvanic and electrolytic cell. And you must also be able to understand the differences in terms of energy transfer. One convert chemical to electrical, and the other one convert electrical to chemical. And one must be able to know the structure of a galvanic cell and its application. You need to be able to represent the galvanic cell in the something called cell notation. You must know the functions of the salt bridge in a galvanic cell. This is very important. And one must also be able to understand the standard conditions that are actually needed for performing in performing electrochemical cells. You need to be able to write down the half reactions for both reduction and oxidation using the standard potential table, which we're going to talk about. And also you need to identify the oxidizing agent and the reducing agent when we're given a half reaction. And also you need to be able to write the net ionic overall reactions for a redox reaction. And you must be able to calculate the cell potentials using E cell, it's E cathode minus E anode. You must be able to define what is an electrolysis, application of electrolysis, which takes place under electrolytic cell. The examinable one, it's electroplating, electrorefining, and decomposition of copper chloride. But it might not be on copper chloride, but they can use another compound beside copper chloride. Right, without wasting time, ladies and gentlemen, let's now start. So I'll just first explain what is an oxidation number. But let's just start on the definition of reduction and oxidation in terms of electron transfer. So let me just stop sharing this one and share another one so that I can be able to explain what the concept that I want to talk about here. Then now, number one must be able to define what is reduction and oxidation. So let's just start. First one, it's a reduction. You need to be able to define what is reduction in terms of electron transfer, and also you must be able to define what is oxidation. Right, in your syllabus, reduction is defined as the gain of electron. Reduction is the gain of electron, is defined as the gain of electrons, the gaining of electrons. When a substance gain electron, then we say it undergoes reduction, and oxidation is the loss of electron, the loss of electrons. So this is in terms of electron transfer. If they say define the term reduction or oxidation in terms of electron transfer, then you have to say reduction is the gain of electron and oxidation is the loss of electron. So in other ways, if a substance gains electrons, gains an electron, then we say this substance undergoes reduction. It undergoes a reduction because it has gained the electrons. But if a substance loses its electrons, then we say this substance undergoes oxidation. It undergoes oxidation, which means that in order to remember this, you can use something called oil rig, which stands for the oil is the oxidation. Oxidation is the loss of electrons. Oxidation is the loss, whereas reduction is the gain of electron. Oxidation is the loss, and reduction is the gain of electrons. So this is what you need to know if they say define the reduction or oxidation. So reduction is the gaining of electrons, and oxidation is the loss of electron. This is according to the electron transfer. This is according to the electron transfer. If they say define reduction or oxidation in terms of electron transfer, then you have to define it in this form. But if they say define oxidation and reduction in terms of oxidation number, in terms of oxidation number, in terms of oxidation number, then you have to define it in this way. Right, in terms of oxidation number, number one, a reduction is defined as a decrease in oxidation number. If a substance decrease in terms of its oxidation number, we say the reaction it undergoes reduction, oxidation number. A decrease in oxidation number is called reduction, whereas an increase in oxidation number, it's called the oxidation. An increase in oxidation number. If there is an increase in oxidation number, we say the substance undergoes oxidation. A decrease in oxidation number, it's reduction, whereas an increase in oxidation number, it's oxidation. So it's very, 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 very important. So it means if a substance has a decrease in oxidation number, is a substance that is actually gaining electron. But when a substance has an increase in oxidation number, is the one that undergoes oxidation. So it's very important to be able to understand that. But now in the concept of oxidation definition, one must be able to know what is an oxidation number. Let's talk about an oxidation number so they can be able to represent this. Right. Number one, this is grade 11 work. Oxidation number is a number. The oxidation number is a number assigned. The number that is assigned to each element, in a compound, but it might not be in a compound only, but also on just a pure element, we can also assign an oxidation number. So it means it's a number that is assigned to each element in a compound. It's called an oxidation number. For example, if we say we have sodium chloride, so it means on these, because we have two elements here, we can assign something called oxidation number on each element. So this is called oxidation number. But you need to know the rules of assigning this oxidation number. Let me talk about it. So it's very important. It means it will need us to use a bit of a periodic table. Periodic table, it's very important. So, but let me now just try to address it. But I'll just focus on the most important one, which I expect, especially the examinable. Right, let me start here. Just a minute. Right, let's start with the rules of oxidation numbers first. So let's talk about the rules of oxidation number. The rules of oxidation number. Rule number 1. The oxidation number of a pure element, the oxidation number of a pure element, it's 0. The oxidation number, I'll just write ON to represent oxidation number. The oxidation number of a pure element is actually 0. A oxidation number of a pure element, it's 0. Pure element. No, I'm not talking about a compound. I'm talking about an element. Secondly, I'll give you an example. The oxidation number of an ion charge, of an ion actually. The oxidation number of an ion is an ion charge itself. So the oxidation number of an ion is an ion charge. We just take the charge of that ion. And okay, here's an example. Imagine when we are just given magnesium. Make magnesium on its own, it's an element. It's not an ion, but it's an element. So which means magnesium here will become a pure element. It's a pure element. So the oxidation number of a pure element is 0, which means on this magnesium will assign a number, and this number would be 0. So it means the oxidation number of magnesium is 0. Why? Because it's a pure element. It's a pure element. So it's very important for one to be able to know that. Again, let's talk about when we have an ion. This time around, we have magnesium ion. So we have magnesium ion. It's an aqueous solution. So this is an element. This one is an ion. But this one is a positive ion. So now it's a cation. Actually, it's a cation. It's not an anion. Anion is when you are dealing with negative ion. For example, sulfate ion. So this is an example of an anion. It's also an ion, but it's an anion. So the oxidation number of an ion, it's an ion charge, which means the oxidation number of magnesium ion is just the charge on its own. So it's just 2. So it means the oxidation number of this one is 2. I believe you're following. Very important. I'll just address the ones that I know they're examinable in the, like, yeah, I'll create a video where I will explain like all other rules of oxidation. But here I wanted to talk about the ones that are relevant to the electrochemical reaction. Then number 3. Number 3. The sum of the oxidation number the sum of oxidation number on a compound is 0. So when you are given a compound, then you add their oxidation number. There must always be 0 if it's a compound. Remember, compound, it's when you have more than one element. It can be an ion, or as long as it's a compound. I apologize. The sum of the oxidation number of a pure compound, not necessarily an ion, of a pure compound is 0. But if we talk about this, so it means the sum of the oxidation number here of this ion will be -2. So this must add up to -2. But if it's just a pure compound, for example, if we have, let's say, calcium carbonate, so the sum of the oxidation number, because this is just a compound, should be 0. Very important. It's a compound, not an element. So why is it important for us to know this? Let me explain to you why is it important for us to know this. Right, in the context of defining what is reduction and what is oxidation in terms of oxidation number, you must be able to see from your reaction whether the reaction undergoes also oxidation or whether the reaction undergoes reduction. It's very important. So now I want us to go through the definition by using an example. Remember we said in terms of electron transfer, reduction is defined as the gain of electron, whereas oxidation is the loss of electron. But under oxidation number, we know a decrease in oxidation number, it's reduction, and increase in oxidation number, it's oxidation. Now, let's do one simple example to actually explain what am I actually talking about here. Imagine we have the following. If we say we have, I will just give one example so that we can understand. Imagine we have an ion, let's just call this ion charge, A+. And I want to write these two reactions in two ways. Let's say this ion, we add 2 electrons on it to produce A as a solid. Then I'm going to change it this time around. It's A as a solid. That gives rise to A 2 plus, then aqua plus 2 electron. So these are two reactions, number 1 and number 2. If we were to look at this, actually, if we were to look at this in the context of reduction in terms of electron transfer, you will realize that from the reaction, I want to explain this, from the reaction, this ion has actually gained 2 electrons and to form A plus as a solid. So because of that, you can easily see that this substance has gained electrons. And we know that when a substance gains electron, we say it undergoes reduction. So it means this half reaction, actually this reaction, we wrote it in the form of reduction. So this one, it means it has given away its electron. So it means this one will undergo oxidation. But now I want us to explain this in the context of what is this oxidation number, like what I said. If we look at this, remember guys, this is an ion. This is an ion. And I said the oxidation number of an ion is an ion charge itself. So which means the oxidation number of this is just 2. But let's come to this one. This one is just a pure element. And what is the oxidation number of a pure element? The oxidation number of a pure element, like what I said, is 0. So now, let's now compare the oxidation number. Initially, the oxidation number of this was 2, but now the oxidation number decreased. You see, there is a decrease in oxidation number. There is a decrease in oxidation number. But let's come to this one. This is a pure element. This one, it's an ion. It's an ion. So what is an oxidation number of a pure element? The oxidation number of a pure element is 0. And the oxidation number of an ion is an ion charge. So this is 2. So let's compare it. From 0, now it went to 2. You see, there is an increase in oxidation number. And what did I say? I said when there is an increase in oxidation number, it means that reaction undergoes oxidation. And when there is a decrease in oxidation number, the reaction undergoes reduction. So this is very important when you're given a half reaction. We'll talk about that. So you must be able to tell whether the reaction undergoes reduction or oxidation in terms of electron transfer. So it's very, 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 very important to be able to understand this. I want to give you one simple reaction. Let's say we're given the following reaction. I just want to give you a simple reaction so that you can be able to tell which of the two has undergone reduction and which one has undergone oxidation. So you must be able to define reduction and oxidation in terms of electron transfer and also in terms of oxidation number. Imagine if you are given the following, let's just call it an overall reaction, which we're going to talk about later. They're given this, I'll just write it here. I'll just provide an overall reaction. Okay. Imagine you have the following. You are given the following. Let's say you know copper ion plus magnesium. And this gives rise to magnesium 2+, it's an aqueous solution, plus copper as a solid. So now we want to check between the two, which one is actually have undergone reduction and which one has undergone oxidation in terms of this reaction. We just assume you're not given or you're not provided with any standard potential table for now. Okay, the best way to be able to do this is to be able to look at their oxidation numbers. Then that will actually help you, assist you to know whether there was an increase in oxidation number or there was a decrease in oxidation number. Then you can be able to tell. So now it means we are comparing this one with this. We look at the oxidation numbers. All right, if you look at this, the oxidation number of copper, this is an ion. So we know the oxidation number of an ion is an ion charge itself. So this is 2. But now we look at this. This is just a pure element. And the oxidation number of a pure element is actually 0. So let's now compare. From 2, the oxidation number went to 0. So you see, there is a decrease in oxidation number. So it means it's an indication to say copper ion has actually gained 2 electrons to form copper element. So it shows that the copper here, the copper ion has undergone reduction. Because we know reduction is the gain of electrons. And if there's a decrease in oxidation number, then you know, then the reaction has undergone reduction, which means the gaining of electrons and the oxidation number, we can say they are kind of like inversely proportional. If a substance gain electrons, then it means its oxidation number should be lower, or it should decrease. But now let's compare magnesium and magnesium ion. Magnesium is an element, pure element, is an ion. Obviously, the oxidation number of a pure element is 0, but this one is an ion, so it's 2. So what is its oxidation? You see that the oxidation number is increased. And we know when there's an increase in oxidation number, it means the substance, magnesium, has lost electrons. But this time around, it has lost how many electrons? 2 electrons. So it's like when we say magnesium decrease its electron, it's reduced, so it forms this. So you see, if you can transpose this, then we'll have this. It's all the same thing. So you need to be able to understand the two in the context of oxidation number and also electron transfer. Very important. Very, very important. And these are multiple choice questions. You need to be able to understand that. So we define what is reduction and oxidation in terms of electron transfer. We define what is reduction and oxidation in terms of oxidation number. We spoke about that. Now we can move on to the next part. Right. In this session, ladies and gentlemen, we'll be talking about 2 types of electrochemical cells, one being a galvanic cell and the other one being an electrolytic cell. But now, with this, we need to be able to understand the types of electrodes, which we're going to talk about now. So let me first talk about electrode types, which is the cathode and anode, before moving on to the type of electrochemical cells. Okay. I believe you are following. And don't forget to like, subscribe, and hit the bell button. That will be much appreciated. Okay, right. So just a minute. Right, let's now start with the type of electrode. Right, actually an electrode is just a metal or a graphite that is used to conduct electricity. So we'll have the 2 types of electrodes here. Okay, let me just define what is an electrode. An electrode is a metal or graphite used to conduct electricity. So a metal or a graphite that is used to conduct electricity is called electrode. So there are 2 types of electrode in this chapter. The first one is a cathode, and the second one is an anode. So let's first define what is a cathode. The cathode is an electrode. It's an electrode where reduction takes place. So an electrode where reduction takes place is called a cathode. So it means if an electrode starts to gain electrons, so we say that electrode undergoes reduction. Then we also have an anode. Anode is an electrode where oxidation takes place. So in an electrode where oxidation takes place, we say this is anode. So these are the two types of electrode which we're going to talk about in this session. So it's very important to be able to know that. Then another one, you need to be able to know the two types of electrochemical cells. There are two types of electrochemical cells which we're going to talk about now. The first one is a galvanic cell, and the other one is an electrolytic cell. And this galvanic cell is called a Voltaic cell. In other words, they call it a Voltaic cell. Right. Within these two cells have a difference in terms of energy conversion. So we have something called galvanic cell and electrolytic cell. So let's actually talk about the differences actually. We define what is electrode. It's a metal or a graphite used to conduct electricity. We know we have two types of electrode, cathode and anode. But an electrode where reduction takes place, where there's a gain of electrons, then we know it's a cathode. And where there's a loss of electrons, we know it is an anode. And there are two types of electrochemical cell that one must know. We have galvanic cell or a voltaic cell, and we have something called the electrolytic cell. And this is very important, very, 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 very important. So let's now talk about the two types of electrochemical cell in terms of their differences. Okay, all right. I'll actually for now speak about the differences in terms of energy conversion and also in terms of their structures, but I think that will be addressed later. Okay, let me just talk about the differences for now. Number one, under a galvanic cell, and electrolytic cell. Number one, under galvanic cell converts chemical to electrical. Chemical to electrical energy. So it uses chemical to produce electricity. It uses chemical to produce electricity. And one example of a galvanic cell, it's a car battery. A car battery, it's one of the example of a galvanic cell because in the battery has chemicals. Then with these chemicals, then it produces electricity. Very important. This is very, 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 very important. So one must be able to differentiate between a galvanic cell and an electrolytic cell. So galvanic cell convert chemical to electrical, whereas electrolytic cell convert electrical to chemical energy. So this one convert electrical to chemical energy. So what does this mean? It means it uses electricity to produce chemicals. So you do, I believe you are able to get the difference. Then under galvanic cell, we say the reaction that takes place under galvanic cell, it's spontaneous. It means spontaneous reaction takes place. We'll talk about this. Spontaneous reaction takes place under a galvanic cell. Very important, ladies and gentlemen. So a spontaneous reaction takes place in the galvanic cell. And then, whereas in the electrolytic cell, the non-spontaneous reaction takes place. What do you mean by a spontaneous reaction? A reaction that is actually spontaneous is actually called a self-sustaining reaction. It's actually a reaction that takes place on itself. A reaction that takes place on itself. For example, a car battery, immediately when you start your car, the car on itself converts chemical to electrical energy. So we say the reaction is spontaneous. And a reaction that is actually spontaneous, it's seen by something called cell potential. Its cell potential is always bigger than zero. So we'll talk about this. It's positive actually. But a non-spontaneous reaction, it's a reaction that does not take place on itself. It depends on the power supply. If there is no electricity or if there is no power supply, then the reaction will not take place. It's not a self-sustaining reaction. If there is no power supply, it means the reaction will not take place. So it depends on the supply of electricity. Depends on power supply. So if there is no any supply of electricity, then the reaction will not take place. And this is seen by the E cell, it's negative. The cell potential, the E cell, it's less than zero. The E cell, it's less than zero. And number 3, under galvanic cell, the reaction, it's the type of reaction that undergoes galvanic cell, it's an exothermic reaction. We're going to talk about this. Whereas in this one, this is an endothermic reaction. But we will talk about that. And again, when you're going to look in terms of the structure, you'll realize that, but I will just edit for now, but you'll find it. You'll realize that the cathode under galvanic is the positive terminal. Then the anode under galvanic, it is the negative terminal. So the cathode is the positive terminal under galvanic, but under an electrolytic cell, the cathode is the negative and the anode is the positive in terms of its structure. But we'll talk about this. We'll talk about this. Then again, the last one is the issue of electrolytic cell has something called electrolysis. It means electrolysis takes place under electrolytic cell. The process of electrolysis takes place under electrolytic cell. Very important. Electrolysis is just the process whereby electrical is converted to chemical energy. So you see where this it applies, it's the process where electrical is converted to chemical energy. In other book, they say electrolysis is the splitting. is the splitting of ionic or the molten compound by means of an electric current. So the process whereby electric current is converted to chemical energy, that is called electrolysis. It means it does not take place under galvanic cell. So we'll talk about, so it's very important to be able to differentiate between galvanic and electrolytic cell, checking which one is spontaneous reaction takes place, non-spontaneous reaction takes place, and which one has a positive terminal in terms of cathode. And yes, so it's very, very, very important for one to be able to understand that. So these are the things that one must be able to understand, differentiate between galvanic and electrolytic cell. Some of the things I'll talk about them, for example, in a galvanic cell has two half cells, and which are separated by a salt bridge. Galvanic cell has a salt bridge, whereas electrolytic cell has no salt bridge. So these are the things that one must be able to understand when analyzing electrochemical reactions. Very important. Right. For now, I can address, let's say I can address the issue of galvanic cell. We can talk about galvanic cell for now in terms of its structure, how it is constructed, and also what are the reaction conditions, if possible. Okay. A galvanic cell, as I said, is a cell which is separated by, it is a cell that contains 12 cells. And within these 12 cells, they are separated by a salt bridge. And there is a voltmeter connected across the cell. Remember, it is used to convert chemical to electrical. So it means it's using chemical to produce electricity. And the reaction is spontaneous, which means it takes place on itself. It's a self-sustaining reaction. So I'm going to try to draw the structure of a galvanic cell, which is called a Voltaic cell also. So in a galvanic cell, let me just try to draw the structure. We are given two half cells. Within these two half cells, there are electrodes in each cell. There are electrodes. Remember, electrode is a metal or a graphite that is used to conduct electricity. So these are the two electrodes. And these two electrodes, one is positive and one is negative. One is positive and one is negative. And these two electrodes are connected by a voltmeter. They've connected a voltmeter across this. They've connected a voltmeter across this. So now, within this voltmeter, the reason they call it a Voltaic cell is that sometimes in the industries, they don't use they use a large voltmeter, which is called a galvanometer. Which is a voltmeter, but it's a very large one, which is this symbol G. So that's why it comes from the galvanic cell. And within this, there is a salt bridge which is used to separate the two half cells. There is a salt bridge. So now, the first one, I will just explain what's going on here. And within each half cells, there is a solution that it's used here. And this solution is actually called an electrolyte. It's an electrolyte. I'll just write an aqueous solution. So this is an electrolyte. Then already this one here, it's a metal or a graphite, which you can call it an electrode. Electrode. And even this one, it's an electrode. But remember, one is positive and one is negative. And then we also have this inverted U-shaped tube. This inverted U-shaped tube, it's called a salt bridge. A salt bridge. Salt bridge. So it's an inverted U-shaped tube. An inverted U-shaped tube that separates the two half cells. So remember, this is a half cell, and this is also a half cell. So this actually, so this U-shaped tube, this one, this U-shaped U-tube is called a salt bridge. Sorry. Which means from these, the positive terminal, because we are dealing with a galvanic cell or voltaic cell. A galvanic cell, positive terminal, it's always a cathode. Negative terminal is the anode. Which means at the anode, it's where oxidation takes place. It is where there is a loss of electron. And at the cathode, that is where reduction takes place. So which means from this, we can easily see that since the anode is the one that loses electron, it means electron will flow from anode to cathode. So the direction of electrons, it means electrons flows from anode to cathode. So if electrons are flowing from anode to cathode, which means we can say the cathode in sometimes could have an increase in mass. Whereas this one could have a decrease in mass because electrons are flowing from anode to cathode. So it's very important to be able to know the structure of a galvanic cell. Also know the components of a galvanic cell. Remember, galvanic cell has two half cells, and these two half cells are separated by a U-shaped tube, which is a salt bridge. And the electrode with two electrodes which are immersed in the electrolytes, which are just aqueous solution. And there is a voltmeter connected across the electrodes. And always electrons flow from anode to cathode, and the reaction is spontaneous. So now there are some instances where you find that they say, change this, we can represent this galvanic cell, not in this structure, but using something called the cell notation. So a cell notation is just a way of representing a galvanic cell, but not actually drawing, but in the form of symbols. So this is how we represent a galvanic cell. Number one, we have something called, this is vertical lines. This is a symbol for salt bridge. So within the salt bridge, this is a symbol for salt bridge. This compartment is for the anode, and this one is for the cathode. So it means the anode and the cathode, in between them, we have a salt bridge. And within the anode part, we must have the following. The first one, we have to have an electrode. Usually it's a metal or a graphite. Then we have something called a phase boundary or an interface. A phase boundary, this is a symbol for a phase boundary. In another book, they call it an interface. Then we start with an electrode, followed by an electrolyte. So we start with the electrode, followed by an electrolyte, which is an aqueous solution. Then on this side, we also have a phase boundary, but we start with an electrolyte, then followed by an electrode. So it means the electrolyte should be in. The electrolyte should be outward. So always we start with the anode, cathode, anode, salt bridge, and cathode. And what's the best way of remembering this? You can remember this cell notation by using this system, which I used to, like, it says andile, andile. It's andile, apologies, andile, cell, coffee, andile, cell, coffee. So which means andile is the anode, cell it's a salt bridge, coffee it's cathode. So if you want to recall on how to draw the cell notation, always andile, cell, coffee. The H for the anode, cell, S, salt bridge, apologies, C it's for coffee. So you start with the anode, salt bridge, cathode. But from the anode, they must be separated by an interface or a phase boundary. In another book, they call it an interface. Now I call it a phase boundary. This is a phase boundary. This is a salt bridge. So you must be able to know that. And again, you need to be able to know the function of a salt bridge. The function of a salt bridge. Very important. One must be able to know the function of a salt bridge. Let's talk about them. One must be able to know the function of a salt bridge. So one must be able to know functions of a salt bridge. Salt bridge of a salt bridge. Number one, the salt bridge complete the circuits. It completes the circuit. Secondly, it maintains electrical neutrality. It maintains electrical neutrality by separating the 12 cells. So it completes the circuit, it maintains electrical neutrality by separating the two cells. So these are the functions of a galvanic cell, ladies and gentlemen. And these are exam typical questions. I'll explain what does this mean. Usually in the salt bridge, they put something called an inert reaction. I'm saying inert solution. So inside this, they put an inert solution. Remember, an inert has to do with unreactive. So they put a solution which will actually not react with this with the electrolyte. Its use is just to maintain electrical neutrality so that whatever is in the cathode should not go to the anode, and whatever is in the anode should not go to the cathode. So what the solution does is that the salt bridge on itself, they put a solution whereby the positive ion of that solution will go to the cathode compartment. So a cation or a positive ion will flow to the cathode, the side, and a negative ion will go to the anode. But usually they use something called cotton wools to block so that the solution should not come. But usually they use this inert solution. It means on the anode we have the N ion. So these are the things that you need to actually understand, ladies and gentlemen. So it's very, 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 very important to understand that. So I'll continue with the second session to actually explain more about this galvanic cell in terms of writing the cell notation and how to actually use the standard potential reaction. Thank you very much for listening. Take care. Bye-bye.